Solving for a variable is one of the most needed skills for any high school or college class, while also appearing in many jobs. To solve for a variable, or in today's case, x, means to isolate x to find the value of x that would satisfy the equation, or in other words, make it true. First, you need to understand what a variable is. A variable is a number that can change, or a specific unknown number. For example, imagine you have 6 apples, but you want 10. You're unsure about how many more apples to collect, so you can have 10 apples total. By creating an equation with a variable, you can find out how many more apples you need. To solve for a variable, you must understand two important concepts: inverse operations and reverse PEMDAS. Inverse operations are exactly what they sound like, operations that are opposite of each other and cancel each other out. For example, if you have 10 pencils and you get 5 more, so you add 5, but someone takes away 5 pencils, then you end up with the same amount of pencils you started with, 10. This is because the plus 5 and the minus 5 cancel out. The same thing happens when it comes to multiplication and division. Let's say you have 10 and you multiply it by 5. You end up with 50. Now, if you take that 50 and divide it by 5, you end up with 10, back at your original number. This is because the times 5 and the divided by 5 cancel out. Radicals and exponents are also very similar. Reverse PEMDAS is exactly what it sounds like. You use PEMDAS when attempting to solve an equation, but when you're solving for x, you're looking to undo an equation to find a specific part. Therefore, you go in reverse order. So first you do addition and subtraction, second you do division and multiplication, third exponents, and finally parentheses. Let's start off with our first example. 6 plus x is equal to 10. Here we can see that there are two terms or parts on the left side, 6 and plus x. The only operation here is addition, so you don't have to worry about order, but we want to isolate x to make sure it's alone. To isolate x, we need to get rid of this 6. To do that, we're going to use inverse operations. So to get rid of this positive 6, we need to take 6 away. We do this by subtraction, so we'll subtract 6. But whatever you do on one side, you need to do to the other. So on this side of the equation, we'll subtract 6. Now, all we need to do is simplify. So here, the 6's cancel out. We're left with x on the left side, and we're left with 10 minus 6 on the right side. We can simplify this further by doing 10 minus 6. So x is equal to 4. This will be your answer. It's also always best to check your answer. We can check our answer by plugging in our answer for x into the equation. So here we have 6 plus x is equal to 10. We can substitute this x for 4, our answer over here. 6 plus 4 is equal to 10. You can simplify this side into 10. And here you can see that the equation is true. 10 is equal to 10. As the equations get more complex, you'll be required to perform more operations. But once you master the basics, you'll be able to solve any similar problem given to you. Next are two-step equations. Here we have 5x minus 3 is equal to 22. Note that now we will be using a dot as a multiplication symbol. Do not confuse this x as a multiplication symbol. Here is where reverse PEMDAS comes into play. Here we can identify that 5 is being multiplied by x to make the term 5x, and we're subtracting 3 right here. To cancel out this minus 3, we need to use our inverse operations. The opposite of minus 3 is plus 3, so here we'll add 3 on both sides to balance the equation. Next, we'll cancel out these terms. So we're left with 5x is equal to 22 plus 3. Now we can simplify the right side. We have 5x is equal to 25. Here we can see that x is being multiplied by 5. So to isolate x, we need to cancel out this multiplication of 5. And to do this, we'll use inverse operations. So the opposite of multiplying by 5 is dividing by 5. So on both sides, we will divide by 5. Now, we can cancel out this 5 being multiplied by x over with the divided by 5. And on the other side, we can simplify. So we'll be left with x is equal to 25 over 5. To simplify this, we just divide 25 by 5. X is equal to 5. This is your final answer. We can check our answer by plugging in our answer into the original equation. So our original equation was 5 times x, which we now know is 5, minus 3 is equal to 22. All we have to do is solve using PEMDAS. So first is multiplication. We go 5 times 5 is 25, minus 3 is equal to 22. Now we know 25 minus 3 is equal to 22, so we're left with 22 is equal to 22, meaning our answer is right. Our next example is 20x minus 20 all over 4 is equal to 25. You may think to add 20 on both sides first, but this isn't the case since 20x and minus 20 are all being divided by 4, counting it as division on the PEMDAS scale. The easiest way to solve this is to get rid of this 4 on the bottom. So to do this, we need to multiply by 4 because this 4 is dividing everything by 4. So we multiply this left side by 4, and whatever you do on the left side, you do on the right, and vice versa. So you multiply 4 on both sides. Next, this 4 is going to cancel out itself and this 4. So we're left with 20x minus 20 is equal to 25 times 4. Now we can simplify this right side to 100. And now we're left with our two-step equation. Just like last time, we'll get rid of this constant right here. So to cancel out a minus 20, we need to add 20 on both sides. So 20 plus 20. And we end up with 120 on the right side. And these two 120s cancel out. So we are left with 20x is equal to 120. And finally, we need to get rid of this 20 that's being multiplied by x. And to cancel out multiplication, you do division. So we'll divide by 20 on both sides to make it balanced. And we end up with x is equal to 120 over 20. Then we can again further simplify the right side to just 6. And there's your answer. X is equal to 6. For an equation like this, x over 10 plus 1 is equal to 11, first we need to move this constant according to reverse PEMDAS. So to get rid of this constant, we need to subtract 1 on both sides. So we end up with x over 10. The plus 1 and the minus 1 cancel out. So it just equals to 11 minus 1, which is 10. Now, we need to get rid of this division of 10 on the x. To do this, we multiply by 10 because it's an inverse operation. So these 10s cancel out, and we're left with times 10 on the other side, because whatever you do on one side, you do the other. So we're left with x is equal to 100, and that's your answer. Our next equation is 15x is equal to minus 5x plus 10. So here, in this case, you want to bring the x's on one side and the constants, so terms without an x, on the other. Here, we need to bring this minus 5x on the other side where the 15x is. To do this, we need to cancel out this. To cancel out a minus 5x, we need to add 5x on both sides. So plus 5x and plus 5x. These two cancel out, and this adds up to 20x is equal to 10. Then you go back to the basics. Wait a second. You go back to the basics, and you divide. You need to get rid of this 20 that's being multiplied to the x. So what you do is you divide on both sides by 20, which leaves you with x is equal to 10 over 20, or in other words, 1 over 2. Similar to the last problem, we have 10x minus 3 is equal to 5x plus 7. So again, what we want to do is bring the terms with x's on one side and the constants on the other. So let's first bring this 5x on the other side. To do that, to cancel out a plus 5x, we need to subtract 5x on both sides. So minus 5x on this side and minus 5x on this side. Then we can simplify this to 5x minus 3 is equal to 7. This is another two-step equation that we learned before. Now, to cancel out this minus 3, we need to add 3 on both sides. So plus 3 plus 3. We have 5x is equal to 10. Again, to cancel a 5 that's being multiplied to x, we need to divide by 5. And again, do it on both sides to keep it balanced. And we end up with x is equal to 10 over 5, or in other words, 2. This is your answer. Our next example is 3 times x plus 1 is equal to 5 times x minus 5. So this may seem intimidating at first, but it's not that hard. What you want to do first is just distribute the numbers on both sides. So let's do the left side first. 3 times x is 3x, and 3 times positive 1 is just positive 3. On the other side, we have 5 times x, which is just 5x, and 5 times minus 5, which is minus 25. Now, we can just solve like our past equation. We bring the terms with x on one side and the constants on the other. So, to bring this 5x on the other side, what we want to do is we want to subtract 5x. We want to subtract 5x. Now, 3x minus 5x is minus 2x. And plus 3, since we have this term right here, is equal to minus 25. Now we just solve like a two-step equation. To get rid of a positive 3, we subtract 3 on both sides. So minus 2x is equal to minus 25 minus 3 is minus 28. Sorry for that, bad 8. And then what we do is we divide by negative 2 on both sides. So negative 28 divided by negative 2 is equal to 14, because the negatives cancel out. Now we are going to be moving on to equations with radicals. If you don't know anything about radicals, check out the other videos I've sent. Working with radicals may seem tricky at first, but once you get the hang of it, you'll have no problem. If the variable you're trying to solve for is inside the radical, what you want to do first is isolate the whole radical itself. So in this case, it is because we have the x right under that radical. So to isolate this radical, you want to get rid of this positive 2. Now, like we learned before, we use inverse operations to complete that. So to get rid of this positive 2, we need to subtract 2 from both sides. And that means that this cancels out, and we're left with root 3x is equal to 7 minus 2, which is 5. Now, we need to know the inverse operation for a root. The inverse operation for a root is squaring, so raising it to the power of 2. We need to do this on both sides. So we're going to raise both sides to the power of 2. Now, this raised to the power of 2 and the square root cancels out. So we're left with 3x is equal to 5 squared, so 5 times 5 is 25. Now you just go back to the basics, and we divide 3x by, we divide 3 on both sides to get rid of this 3 being multiplied with the x. So 3, this cancels out, and we're left with x is equal to 25 over 3, which is your answer. It's the same thing with cube roots. So we have the cube root isolated. Now we want to get rid of the cube root and finally solve what's inside the cube root. So to get rid of a cube root, what you do is you raise it to the power of 3, or you cube it. This cancels out the cube root, and you must do it on both sides because you can keep the equation balanced. So this cubed and cube root cancel out, leaving you with x plus 3, which is equal to 2 cubed. Now 2 cubed is 8, because 2 times 2 times 2. So you're left with x plus 3 is equal to 8. Now you want to cancel out this positive 3 to isolate x. To do that, you subtract 3 on both sides, and you're left with x is equal to 5. That is your answer. Finally, we'll be moving on to exponents. For exponents, you want to isolate the variable that's with the exponent. So in this case, it's x, and then our exponent is to the power of 2. So in accordance to reverse PEMDAS, we can see that 10 is being multiplied to x squared. So we need to get rid of that. To do this, we need to divide by 10 on both sides to keep the equation balanced. So this 10 cancels out with the division of 10, and that leaves us with x squared is equal to 1,000 divided by 10. Now 1,000 divided by 10 is just 100. So like we learned in the previous segment, the opposite of squared is the square root, and vice versa. So we need to apply that knowledge here. So what we want to do now is take the square root of both sides to cancel out this squared right here. So since we did the square root on both sides to keep the equations balanced, this squared is going to cancel out with the root, leaving us with x. And we're going to have the square root of 100. Now there's something important to know, that a square root of any number other than a negative and 0 has 2 answers, a positive answer and a negative answer. So we're going to write it like this: x equals plus or minus. Now, what is the square root of 100? The square root of 100 is just 10. So this is your final answer. The reason that the square root of positive numbers always have 2 answers will be explained in depth in a future video. Our final question is 10 times x to the power of 3 is equal to 1,250. So you want to do the same thing as we did before. We want to get this x with its exponent alone. To do this, we're going to divide by 10 to get rid of this 10 being multiplied by this x squared. So we do this on both sides, like always. The 10s cancel out, and we're left with x cubed is equal to 1250 over 10, which is just 125. Oh, so now what we want to do is, like last time, we know that the opposite of cubed is cube root. So you want to apply cube root to both sides. Now, like last time we did the square root, we saw that we had 2 answers. But in the case of cube roots and any odd number root, you're going to end up with 1 answer. And this will be explained further in a future video. So we have this x cubed getting cube rooted. So that's going to cancel out, and we're left with x. And on the other side, we're getting the cube root of 125. Now the cube root of 125 is 5, because 5 times 5 is 25, times 5 again is 125. I hope this video will help you guys understand and finish the given worksheet. If you need further explanation, check out other linked videos. If you have questions, then either email me at newyork15@gmail.com or post questions in the class comments. Have a good week.